So I'm going to take you through the platform. A couple of things before I start. We've really tried to build this platform to make it really user-friendly and as simple as possible. A lot of existing solutions, whether it's existing TDM products or whether it's manual scripts, are incredibly difficult to use. So we've tried to make it as easy as possible for the end user. In terms of how our system works, we essentially connect to a source and a target. Now, that source could be production, it could be an existing test environment, and it could be a relational database, it could be a third-party application such as Salesforce, or it could be a file or a schema. And then the target is generally the system under test or test environment that you're testing against. The reason we connect to that source is so that we can use our machine learning models to analyze the structure of the data, patterns in the data, and essentially automatically get you to a really good starting point of what that data should look like. So the first thing I'll show you is just around data sources and how we set those up. So you can set those up in the system. I've got quite a few set up here. But if we click connect data source, we've got a variety of different options. So I've got, these are just the ones I've got, but we've got relational databases. We've got some older things such as DB2 and sort of mainframe. We've got newer technologies such as Snowflake. And as you can see, I've also got SAP set up and CSV. We generally connect via JDBC, but we also have other options available for connections for packaged applications, such as via API or via an agent utility. And then in terms of authentication, we can connect to a secret manager, which of course most large enterprises use. We then also have, importantly, database permissions, which, again, are really key to set. We always want to make sure that that source we're connecting to, whatever it is a read-only connection. We never want to change anything within that. Once you've set up your data sources, you can then create workflows. So workflows are the way that we automatically understand and show what transformation is going to happen to data. Our three main use cases are around data masking, synthetic data generation, and data subsetting. And we can actually do all of those in one workflow. So if I come over to a masking flow, you can see that we have a data as a code approach. Now, this allows us to essentially go down and configure data to the lowest level. But importantly, in this scenario, this has actually all been generated by our machine learning. So I haven't had to do any of this. We do also have a database view or a visual view, which you can achieve the same outcomes, but it's a less code approach. The first thing I'd do in a masking sense is I'd come over to our sensitive data scan. So what I can do is I can run this scan, and this will go off to the source. And again, it will automatically use our machine learning models that are pre-trained to look at the structure of that data, the structure of that database, the different tables, the different column names, the data type, and it will essentially come back and look at also samples of data within those columns. And it will come back with this report, which automatically is identified, in this example, some PII data around first names, last name, emails, etc. It's automatically marked these as sensitive, and this is where a user like myself can come in and either change these or just accept what the system has given. As you'll see, this is on a fairly small data set, but we've got customers at the moment using this across 400, 800,000 tables. So we can scale this up and down pretty well. What I can then do is I can apply those suggested changes. And what that's automatically done is this has basically made sure that this code here has been updated. So this has then taken all of those different parameters, all those different fields that were sensitive, and it's basically automatically just going to mask them. So to show you this, I've got a demo application. So this is a very simple banking application. And for demo purposes, this view here is our production database. Now, within this production database, we've got customers who've got names, emails, phone numbers. Importantly, all of this data is linked together. So every customer has got an account or multiple accounts, and all of those accounts have then been linked to multiple transactions. I've then got a testing database, which has currently got nothing in it. So if I just purely wanted to mask data, I can run this flow. And if I come back over to my application and refresh this, you see that I've now got exactly the same amount of data in here. But if I actually go into the customers, for example, you'll see that all this data has essentially been masked or scrambled, whilst the structure of that data has been maintained. And again, any area where data has been referenced that's the same within the same database, it's been masked the same. So we have a deterministic model that means if the name Finn is used in multiple locations, it will be masked the same. But you're probably thinking, okay, well, this is good and this means I can use it, but actually I want to have more realistic, names in here, for example. I want to have data that needs to meet validation rules and things like that. So we can do that as well. So on top of our sort of basic masking routine, we can also apply data generators. So if I go into this other masking flow, you see that again, for some fields such as branch name, we've just chosen to mask it. But for other fields, we've actually identified our custom transformers here to actually generate realistic data over the top of those names. So here we're using the person generator. And if I go into this view, it's a bit easier to see. You can see that we've chosen the mode is masking, but we've chosen out of our many transformers here. And again, we can customize this to the lowest level. So whilst we have, defaults for the names it generates, we can change that if there needs to be certain rules in place. If I now run this workflow, you'll see that the same data, again, is still there. But if I come into accounts, you actually see that those names have now been changed and they look really realistic. They've also been linked together. So, the last names that have been generated have actually been incorporated into the email. And again, referential integrity between the system has been completely maintained. So that's masking. What we can also do is we can do generation. So what we do with generation is a similar process happens, but it's a few changes. So by default, what happens with generation is that the system is going off again into that source database using our machine learning models, to essentially understand the metadata of that database. Again, it's looking at columns, data types, and it's essentially looking at patterns of data. It's automatically then choosing for you the different transformers that we have to be able to replicate that data for the non-production environment. But it's actually doing more than that. So it's actually, not only is it choosing a transformer to make sure that it's generating the right type of data, it's also doing statistical analysis on that data to understand the patterns of data, the distributions, to make sure that, if that source is production, that you're mimicking production as closely as possible by default. So if I click on this one, and this is account status, you can see that it's basically done, showing the distributions of those statuses in production, and it's going to mimic those exact statuses in the non-production environment. This is also where we can customize this, though, for edge cases and negative scenarios. So I could come in here and I could say, I want 100% active accounts. I want 0% active accounts. I actually want to add a new status in here that doesn't exist, to see how the system fares with that. So again, all of this is completely customizable, but importantly, all of this is done for you by default. And again, this scales up and down really, really well. What I can do then is I can scale that data up. So I can choose to scale that data up by 5 times, 10 times. I'm just going to do 5 times for now, just to show an example. So again, if we come over to our example application, you can see now that that data has been scaled up. And you'll notice that not all of it has been scaled up. And that's because within the config, we actually defined 5 times the amount of data at a global level, but actually at different table levels, we defined different values for what we need. So we can really control this at the highest or lowest level. What you'll also see is that, again, new customers have been generated. And now they've been generated completely from scratch. So they haven't been, unlike masking, where masking took the original values and passed some of that through and then changed some values. All of this data has completely been generated from scratch, whilst understanding and looking at the patterns of that data. So again, you can see the linkages between data, but importantly, the referential integrity has been maintained. So for every customer that was generated, 1 or more accounts was generated. And for all of those different accounts, multiple transactions were generated. Again, using the statistical analysis, things like amounts actually appear realistic because it's basing it off, the minimum, the maximum, the median values. They exist in production. And again, this is all completely in our control. In terms of subsetting, we can do subsetting across either generation or masking. I'm actually just going to show it on masking. So I can choose to subset, 50%. So I can essentially halve that data. We've currently got a customer who has got about 30 terabytes of data in production. And at the moment, they copy all of that over to about 5 different test environments. Now, that's incredibly inefficient, but also incredibly costly from a storage point of view. So we can subset this data down. And what will happen is that it will automatically understand all the different relationships between data to make sure that those links aren't broken when you reduce the amount of data. So if we come back in here again, as I was mentioning, you can see these numbers don't quite add up to 50% of what we had. And that's because it's got as close to that number as possible, whilst making sure that, again, all that referential integrity is maintained, and that, for every customer, they still have at least one account, and all those accounts still have at least one or more transactions. This really allows you to, again, customize and configure data in any way you need. We also have full audit logs in which we can see, who ran a workflow, how the workflow was run, and also we can generate a report to show, for each different database and table, what transformation happened, how many records did we generate, and also the different transformer that was used for that exact column. We can also integrate with CI/CD. So we have native connections to GitHub Actions, and we also have an API which can be exposed to essentially integrate into your pipeline. Lots of our customers go down this route, and means they can generate their data, do data refreshes continuously through when they run their pipeline. Another key thing to mention is how we deploy our software, and this is a question that comes up a lot. So typically we deploy within the customer cloud. We can also deploy on-premise if we need. And the reason we do that is obviously, as some of the challenges we were mentioning earlier, security is a really, really massive, big thing. And certainly with the use of AI, it's getting even more important. So from our point of view, we deploy it within the customer environment. So the data and everything is completely in their control. We at Synthesized can't access that data, can't access the platform. So everything is completely in their control. In terms of how we operate, we also don't store any of that source data. So even though we may connect to production, we don't ever store any of that data. And all transformations are done in transit. What this also means is that, when we're masking values, for example, it's a one-way transformation. So, someone looking at a masked data set will never be able to get back to that original source data.